Okay, students, now I will talk about another example and you can go and complete it. I'm talking about a movement body move from the origin to the point A, which is 5 in x direction and 2 meters in y direction, and then by moving from A to B, this vector is d2. It moves from 5 to 8 to 9, from 5 to 9 in x direction, and from 2 to 9 in y direction. Then we have a resultant change in position, and this is represented by the vector d. It is move the body from the movement of this body is from the origin to point 9 meters in x direction, 9 meters in y direction. The movement for the first vector, which is d1, and its direction is theta 1, and you can find this theta. It was during 0.4 seconds, and the second vector, second movement, was during half seconds. You can find the magnitude of this vector using the Pythagorean theorem. Also this one, also d. Also you can use the trigonometries to find theta 1 and theta 2 and theta d. You can use sine and cosine and tan, and this is the change in y for the first vector, and this is the change in x for the first vector. This is the change of x for the second vector, and this is the change in y for the second vector. For the third resultant vector, all of this is the change in y, which is 9 meters, and all of this is the change in x, which is 9 meters also. You can find the angles, and by that you can find the direction of these vectors. You can find the components of each vector just by looking d1x. This is d1, and the x component is 5. The y component of the first vector is 2, and so on. These are position vectors, and this one also. Now I need from you to calculate the velocities. The velocity is equal to the displacement divided by the time. Also you can find the length of this vector. The length can be computed as, for any right angle, if this is x and this is y and this is d, I can know that d is equal to the square root of x squared plus y squared. And this theta, and which I need from you to compute it, tan inverse of theta is equal to y over x. And remember here to pick the positive value, not the negative value, because the square root has two values, one positive and the other is negative. I separate this question to pieces for you to compute each vector and each requirements alone. This is the second vector. You can move it to the origin, and this is the resultant one, and this is the final results. You can find the resultant vector from these two vectors. You can add 5 to 4. This is 5 and this is 4. The resultant is 9. This is 2, and this is from here to here. 7, the resultant is 9, and so on. You can complete this question. Now I will move to a question in the worksheet. Question number 1A. I'll complete to solve the first part. The second part you can do it also. Now we have an airplane moving to the west. It has 3 periods of movement. First one, it moves to the west direction directly 30 minutes. Then it's rotate 30 degrees to the north for 10 minutes. Then the 30 degrees from its original motion above the negative x-axis. This is the west, which is negative x-axis. And then it rotates 75 degrees to the south with respect to its original motion. So 75, if I take a minor xy plane here, secondary xy plane from here, then the motion, the rotation about the negative x-axis here, it will be 30 plus 45, it will be 75. Now the direction of the last motion of this plane is 45 degrees below the x-axis. So this is the movement, and I have the green line is the resultant displacement for this plane. Now I can use theta 1 for the first movement is 0 with respect to west, but if I need to use the positive x-axis is positive and the negative x-axis is negative, and this is positive y and this is negative y, I need to take the angles with respect to the positive x-axis. This is 0 with respect to negative or with respect to the west, but it is 180 with respect to the positive x-axis. Okay, so theta 1 for the first movement is not 0 with respect to west, it is 180 with respect to east or positive x-axis. Okay, if I have 30 degrees with respect to west, this like here, this is 30, it is 150 degrees with respect to positive x-axis. Also negative 45, which is respect to the west here for the third movement, if I take a secondary xy plane, this is 180, and I need to add to it to 180 45. The total angle will be 225 degrees with respect to east or to positive x-axis. Now I have the angles with respect to positive x. Okay, I need to compute and to know the velocity vector for the first movement for this plane. The velocity has 2 components, one of them with respect to x in x direction and the other is with respect to y. The x velocity is v1, which is 45 as given miles per hour, and the times here in minutes, I convert them later to hours, and the final computing for and calculations are in miles. Okay, so for the first movement, the velocity is 45, it's constant, and I use here theta 1, which is 180 with respect to positive x, cosine 180 in x direction plus 45 sine, this is a typo, I'm sorry, 180, which is 0. In this case, I have the v with respect to x, vx is minus 45 and vy is 0. Okay, I have v1 x is minus 45 miles per hour and v1 y is 0 miles per hour. Okay, I know that the displacement is equal to the velocity multiplied by the period of time. The time in this state, in the first stage, is 30 minutes. 30 minutes, it is a half an hour. We know that. It's easy to be converted. So the velocity, the first velocity in y direction is 0. If I multiply it by half an hour, it will be 0 miles. The displacement in x direction is equal to the velocity in x direction multiplied by the time. The velocity in x direction is minus 45 with minus sign. Minus sign means to negative x direction. This is it. Minus 45 miles per hour multiplied by half hour. I can cancel hour with hour. 45 with minus sign over 2 will be equal to negative 22.5 miles to the west, because I have negative sign, and 0 miles in y axis. I don't have any movement for the first movement. For the first stage, I don't have any movement in y direction. So this is the first x and y displacement for the first stage. Now the second stage. The airplane finished its movement here, the first stage, and now it has 30 degree above the y-axis, the x negative axis, which is 150 with respect to positive x. Okay. Now the velocity, it is still 45 miles per hour and the time is 10 minutes. So I need to compute for this vector its components. I know that it is v2 as a vector. v2 is equal to 45 multiplied by cosine 150, which is the angle in x direction, plus 45 multiplied by sine 150. This is v2y and this is v2x. Okay, I can compute that. v2x will be 45 multiplied by cosine, which is equal to negative 38.97 miles per hour, and v2y is equal to 45 sine 150, which is positive 22.5 miles per hour. We can see that the velocity in x direction is negative because it is in the west direction, and the velocity in y direction is positive, which is in y positive. Okay, so the final velocity vector is negative 38 miles per hour in x direction plus 22.5 miles per hour in y direction. Okay, I need to compute the distance that the airplane cut and pass in the second stage. The time is 10 minutes. I need to convert the time from 10 minutes to hour. I multiplied by that conversion factor, which is, I need to remove the minute unit and I need it in hour. So I will choose this conversion factor. 1 hour, this conversion factor is equal to 1. We know that 1 is equal to 1 hour over 60 minutes. They are the same, so I cancel minute with minute. The last answer will be without is 10 over 60. 10 over 60 is 1 over 6 hours. This is delta t in the second stage, with I name it delta t2. Okay, now I need to compute the x displacement and the y displacement for this stage. Delta x is equal to the velocity in x direction multiplied by the time period. The velocity in x direction is negative 38.97. We compute it here. Miles per hour multiplied by the time. Hour with hour is cancelled. Then I have the rest unit is miles with negative sign. So the change in position in the second stage is negative 6.495. I can round it to 5 here, miles. And the same way is used to find the change in position in y direction. This is the velocity in y direction, and this is the time, and the change in position is positive 3.75 miles in positive y direction. This is in negative x direction. Okay, this is the second stage. Now I will move to the third stage. This is the second stage, but the airplane turns 75 as we talked before. This 75 makes the angle with respect to positive x is 225 degrees. So the velocity vector will be, in this case, v3 is equal to 45, which is the constant speed for the airplane, multiplied by cosine 225 in x direction, plus 45 sine in y direction. Okay, I need to compute now again and again the x component of this velocity in the third stage. 45 cosine 225 is equal to negative 31.82 miles per hour, and the y component of the third velocity, or the third velocity, or the velocity in the third stage, is negative 31.82 miles per hour. Now the last view of our velocity in the third stage is negative 31.82 miles per hour in x direction, negative 32.82 miles per hour in y direction. Okay, now the time what I have is 25 minutes. I need to convert it to hours. By the same way, I will multiply by 1 hour over 60 minutes. The answer will be 25 over 60 hour. Okay, I can compute the x component, or the change in position in x direction for the third stage, in this, using this law, which is x equal to the velocity multiplied that by the time. The velocity is negative 31, and this is the time, 25 over 60. Hour will cancel with hour, and the final unit in miles, which is negative 13.26 miles in negative x direction. Okay, also the same for y position, or the change in position y direction for the third stage. It will be also negative 13.26 miles. You need to see that, to notice that the change in position for the third stage in negative direction in x and in negative direction in y. Okay, altogether we now have 3 change in position in x direction. The first stage, the second stage, the third stage. The first one negative 22.5, the second negative 6.5, third negative 13.26 in miles, and the change in position with respect to y direction. The first stage 0, it will not, it didn't change its position in y direction. The second stage, the airplane changed its position 3.75 miles in positive y direction, which means to the north, because this is east and this is west and this is south. Okay, and the third stage negative 13.26 miles. The total change in the position in x direction is the sum of all of these, which is negative 42.26 miles. It's in negative sign, means in the negative y direction, or the x direction, I'm sorry, which is to the west. This is the problem with this. Okay, and the total change in position in y direction is negative 9. That's mean in south direction. I'll draw this xy plane. Positive x means east, this is north, this is west, and this is south. Its change in position negative 9.5 miles. This is negative 9.5. Approximately it's the same scale for its movement. And negative 42. This is negative 42.26 miles. And this line represents the total change in position. This line represents the displacement from the origin till to the end point. And this is the first stage. This is the second stage. It rotates in 150 degrees. This is 30. And this is the third stage in its angles, and its direction. Its direction from here is 45. And I can compute this. The total displacement, I name it D capital. It is negative 42.26 miles in x direction, minus, or negative direction in y direction, 9.5, which are the same quantities here, total quantities. And the total length of this displacement, using the Pythagorean theorem, it will be squared x changing x squared plus y squared, which is equal, and using the square root, so the total displacement will be 43.3 miles. And we can find this direction, which I name it phi, or phi, you can name it, I don't know the right word. It is phi. Okay, tan phi is equal to delta y over delta x, because we have a right angle triangle. This is delta y and this is delta x, and this is phi. The two sides, y and x, tan theta is equal to y over x, and phi is equal to tan inverse for delta y over delta x. And in this way, phi is equal to 12.7 degrees below the negative y-axis, or below the west direction, between west and south direction, which is equal to, if I add 180 degree to this angle, it will be 192.67 degrees with respect to positive x-axis, or east. This is the first part of this example. you can solve it faster than me. I solve it slowly, and because the explanation, you can solve the part B, and you can go and finish this worksheet. Thank you.